Hi, everyone. My name is Mark Tehan. So I'm a solution engineer with Confluent. It's a pleasure to be doing Apache Kafka meetups again. So I don't know if any of you were at the very early ones, like 4 or 5 years ago. I did a whole bunch of them back then. This is the first time I've done one in a long time. It's great. Thank you very much, ByteDance, for hosting tonight. It's really a great event. So today I'm talking about benchmarking Apache Kafka, because this is a question that kind of comes up a lot. Exactly how much data can a Kafka system take? I'm kind of making an assumption here that everybody knows what Apache Kafka is, knows what it does. If anyone's very new to Kafka, you can raise your hand a tiny little bit so I know. Okay, so some people are fairly new. So I won't assume that everyone is kind of clear on it. Oh, let's see. Okay, so I'm a principal solution engineer. I've lived here like for years. I'm in Singapore, of course. I lived here for 20 years or so. And most of what I do is designing like streaming systems. So how many brokers? Is it one data center or one data center or two data centers? Is it SaaS? Is it whatever? And one of the questions that comes up an awful lot on all of this is, how fast can it go? How much data is going to flow through a system like this? And for those that don't know the history of Kafka, it actually came from LinkedIn. LinkedIn, generated Apache Kafka 12 years ago because they needed something to do this social media feed. They needed something that could send data out to. And back then it was millions of users. Now it's hundreds of millions of users that are online at the same time, and it's a customized feed. Now all the social media companies can do this, but this was a really, really hard problem 12 years ago. And it was not a problem that you could fix with a database, because they tried with databases for a couple of years. They couldn't do it. And that's how Kafka came about. So, and now it's sort of gone, it's spread out to any business that really needs real-time data. Uber and Grab and these sorts of companies are super examples of companies that really built a whole new business based on the fact that you can get streaming data now. And now you find it in banks, insurance companies, government, all over the place. Everyone's kind of using Apache Kafka. If you want to get in touch, LinkedIn is the best place to reach me. So for my talk today, I am going to be, I keep losing focus. So mine is fairly technical, and I'm going to be sort of starting up Kafka on my laptop as well and talking through some stuff. You can reach us. This is the Kafka group that we're in here. We also have a community. If you want to try any of this stuff out on our SaaS product, you can. I'll show this slide at the end again. There's like $460 of usage because we had this extra usage put on for the meetups. Talk about that a bit later. Okay, so benchmarking is really quite a journey, right? You have to think about several things as you're doing it. So we'll talk a little bit more about Kafka internals, like we did in the first part. And then we'll talk a bit more about goals. If you're trying to benchmark something, how do you know what it is that you're aiming for? What does success look like? And then when we're configuring the clients is really important, much more important, I think, than configuring the actual cluster. The configuration for your producer and your consumer is really important. And then where do you take it from there? My belief is that you should have the ability to benchmark your cluster anytime, because you will do different things to your system that will affect the performance or on your network or in your data center or whatever. And it's good to know, is your system behaving normally now? I spent years and years as a DBA, and you keep getting this question, my system is slow today. And it's really good to have a figure, a number, something that you can take back to your clients and say, no, it's actually normal. It's the same as it was yesterday. The resources I'm using for this are 2 blog posts that we put out quite a long time ago. One is 2017, one is 2020. So optimizing your Apache Kafka deployment, most of the content comes from this. This is a 6-minute read, and then the 99 percentile latency at scale, which is a 23-minute read, a huge blog post. And it goes into real depth on this tail latency. What are the things that slow down your consumers, like at the very end, when you've kind of tuned everything, but every now and again, you just get a really slow consumer. What are those tail latencies that cause this problem? So I have some references from this talk, from this in here as well. So there's always a trade-off. When you're trying to do a benchmark, you always have to say, well, I need this more than I need this. And we break it down to sort of non-performance objectives and performance objectives. So non-performance is business, right? If you're building a payment system, you're going to need durability, right? You have no tolerance for lost data. You have no tolerance for duplicate data. And that's the primary thing that you have to design your system for before you go and start doing your benchmarking. It has to be durable. Okay. So durability, availability, and ordering, these are common requirements when you're building out a new Kafka system. Many of the instant payment systems that we're using now, we've all gotten so used to just peer-to-peer payments. Pretty much all of them use Kafka. You know, it's the one thing they all have in common, because it's a great streaming platform for doing something like real-time payments. And those are all durable systems. You're not going to tolerate your payment getting lost, right? So the sysadmins for these know that. And then once you have your non-performance objectives laid out, then you look at things, how do you balance off throughput and latency, right? How much data do I push through the system and tune it just as a big pipe versus latency? Like what's the response time that I get for each producer? How low can it go? Kafka is not the same. Kafka is not the same as something like a HFT trading system that a bank might use for doing trading, where you're doing super low latency type streaming. It's a different thing. Kafka is a general purpose streaming engine, and it doesn't aim to have super low latencies. Now you can get it very quick, and often when I'm talking to people about designing their systems, you know, we look realistically at what a reasonable produce is. Sometimes they come, I've had clients that say, I want 2 milliseconds. I want to send a megabyte and get a response in 2 milliseconds. And we go, well, you know, it's that you really need specialized hardware and software to do something like that. But what happens if it's 20 or if it's 100 or if it's 150? Tell me what the business requirements are. So kind of clarifying all that is important. The 4 different sort of tuning goals and the first link that I gave are throughput. So your logging system, you're pumping all of your log files to go to, say, S3 or Elastic. That type of system would be tuned for throughput. Durability, stuff like payments, anything that a financial services company is running. Latency and next best offer. If you're doing point of sale, why don't you buy this? You know, getting response back to the consumer is super important, and you will tune for a latency goal. And availability. If you have a single Kafka cluster with 30 brokers and you're running 150 applications, that's all about availability. You never want your system to go down no matter what you do. So that's the goal that you aim for. Okay, so we're going to take a look at producers and consumers, not going into too much depth on it. And then I'll start up a system and sort of show you some of this. So the producer is like your streaming publisher. It's how you push the data into the system. It's doing the insert, essentially, for the database people. And there are 5 sort of phases that a producer has to go through to get the data from the consumer, from the client. So that could be Java or .NET or Go or Python, something like that, all the way into the broker where it's available for the consumers. So it has to serialize the data. It has to partition the data. Now, by default, Kafka systems have parallelism of 1, which is 1 partition, and it just drops it into that partition and sends it on. The record accumulator, how do we batch the data before we send it from the client up to the broker? The compression, once we've got a batch ready, we can optionally compress it. This is so often overlooked. But by the simple thing of changing your producer.compression to gzip or snappy or zcat, you can instantly have the amount of data that's on your broker storage. It's almost like magic for people that haven't turned on compression. And by the way, compression is completely transparent. You might think, well, I have to change all of my consumers so that they can decompress. You don't have to. It's built into the client. It'll automatically detect the batch is compressed, and it'll automatically decompress it. Your consumer application never has any idea that data was ever compressed in the first place. And then the sender thread. Okay, so there are various properties that affect these. We're not going into too much depth on these, but I'll show 1 or 2 of them as we sort of show a bit of a demo. Batching is really important. So this is from my colleague. You know, it often happens like this, that you're running a system and when you tune the batch and you say, all right, I don't want to send 1 megabyte of data at a time. I'm going to send 256 kilobytes of data at a time. Or I'm going to send 2 megabytes of data at a time. It depends how bursty the data that's coming in to the producer is. Is it a microservice that's sort of sending very small, frequent messages? Or are we sourcing data from CSV files? Are we getting it from a messaging system? And we're just getting big wads of data coming in. We want to have huge batching. So, you know, this sort of pattern is very common, right? When you find the right batch size for the shape of data that you're processing, it really, you have a very big improvement in performance for the system. Okay, and it hits you at 3 layers, right? When you actually improve the batching, so the producer to the broker, that's obvious, right? We're batching better, the data is getting to the broker faster. And then broker to broker, because Kafka is a distributed system. You must have 3 brokers or more. Anyone that's running like a 1 broker or a 2 broker, you know, I think you know yourself, you should be running 3 or more. And then you can go up to hundreds if you want to. But the data has to be sent from broker to broker. So if you batch it properly, that also becomes more efficient. And then the broker to the consumer, whoever's reading that data, also benefits from the fact that you tune the batch in the first place. Okay, so this really does make your whole system more efficient. And it's actually very similar for compression. You really get the same benefits, all of these sorts of same benefits when you just turn on compression on your system. So both of these are totally transparent to your consumers. If you have an app running now in Java or .NET or something, you can change both of these and it has 0 impact on your app. You don't have to recode, redeploy, recompile anything, okay? Okay, so I'm going to start up a demo on my laptop. I'm going to run Kafka on Docker. For anyone that's never run Kafka on Docker before, it's a really super way of testing things out because you can start a distributed system on Docker, right? You can have multiple brokers. I'm starting a single Zookeeper, 4 brokers, and a Squid proxy, just so because I'm sending JMX metrics up to a dashboard that we can have a look at. There are other services with Apache Kafka. So the schema registry, Kafka Connect, KSQL DB, a stream processor, a REST proxy for producing and consuming via HTTP, and a control center, which is one of the enterprise products. So we're not starting any of these because once I start these, my laptop sort of has a shelf life in terms of battery and CPU before it all sort of dies. So I have to put down the microphone while I start this, one sec. Okay, so on my Docker, I have nothing running at the moment, so I'm just going to do a Docker compose. Okay, so this will take a few, probably about a minute or so to start. So I'll let that sort of scroll and run. And it'll be starting up Kafka 1, 2, 3, and 4, and then it'll stabilize and sort of settle down a bit. Sure. Yeah, so the question is, when is Zookeeper going finally? So Zookeeper is going finally, but we've been saying that for about 3 years. So yes, towards the end of this year, September, October, there'll be the first production release of Apache Kafka that's it's not supported, but recommended that you can run without running a Zookeeper service for consensus. And similarly, Confluent, we will have a version of Confluent that sort of accompanies that. So the end of this year, if you want to run Kafka at production grade with no Zookeeper, end of this year, there's still a process that has to do consensus. Something still has to manage the brokers and say, okay, I have 3 or 4 brokers in my cluster. I'm adding one, I'm removing one. But that responsibility moves to a thread inside the Kafka broker itself, rather than having to have a separate Zookeeper for that. So end of this year. So the question is, how seamless will the migration be? If you're currently running a bunch of Zookeepers, you probably have 3 Zookeepers or 5 Zookeepers and however many brokers. There will be a process to roll through. So you basically shut down a Zookeeper, start up a consensus node, shut down a Zookeeper, start up a consensus node. So you will roll the Zookeepers to shut them down and roll the consensus nodes to bring them up, and one will replace the other. So you shouldn't, now this, I haven't tried it myself yet because the release is not out. It's being built at the moment. But the idea is it'll have to be seamless because so many Kafka systems that are running in the world, you just can't shut them down. I mean, Uber's not going to shut down their system just because they're switching off Zookeeper, right? So it will be seamless for sure. Okay, so so we're up and running. It's stabilized. There's nothing complaining, so that's good. So I probably have about 20 minutes till my battery dies, and we'll come back to that in just a moment. So everything I'm showing today is on my GitHub. So Mark Tehan, Benchmark Meetup. So the Docker Compose, the produce max megabytes per second, which I'm going to use, and then just the Squid auth. Let me just take a quick look into the Docker Compose. So each broker is here. So Kafka 1, running on 9091. I'm giving it a broker ID of 1, setting the rack ID, and then some stuff on sort of rebalancer. And then we can either choose to send the metrics to a cloud console, which is what I'm using, or you can use sort of this is the one, the cloud console that I'm sending the metrics up to, just so we have a dashboard to see in just a moment. Okay. Okay, so the performance tools, the command line tool that we're going to use is Kafka Consumer Perf Test and Kafka Producer Perf Test. These come with the Apache Kafka client under the bin directory. So alongside things like all of the other Kafka command line tools, these are there. But they're actually quite rarely used, which is a shame because they're actually really, really powerful. And it's a built-in benchmarking tool that you don't have to go and build something in JMeter or in Python or everything. It's actually all built in already. The way it works is you just give it a bunch of parameters, the usual stuff like bootstrap servers and all that, but you tell it how many records do we want to send to the broker, what size, what's the topic, the throughput, and basically I'm not sure, I think this is per second, and whether we want to print the metrics. So this is the core of doing any benchmarking. You set up a Kafka producer perf test first, and this pushes data in an exact size and shape that you want. If you want 1 megabyte per second or 10 or 100 megabytes per second, then your producer perf test can push exactly that amount into a topic. And then you run the consumer perf test, and the consumer is doing the opposite. And the idea is you need to check that the consumer receives 100% of the data that was sent in by the producer. So it's not only a test of how fast can my system go, but it's a good way of shaking out your system and doing a smoke test and making sure that everything's working. Because you can run these and then you can roll your brokers. You can shut down broker one, watch all the leader elections happen. A number of threads will pause while leaders are elected, and then it should continue and resume. And we do this with our customers. We run these utilities to make sure that everything on the system is functioning correctly if we're doing like multi-site DR or something like that, okay? For each, when you're doing a produce, you need to look at metrics. There's a few different approaches you can take. I'll show you, I'm going to log into one of them, which is, there is actually a hosted monitoring console that we provide called Health Plus. So there are myriad Kafka monitoring tools that you can download and run on your laptop. I don't want to run something on my laptop because I'm already stressing it enough. So these are the various clusters that are running, and you can see they're all red except for one because these are the ones I was testing. So this is my cluster. And basically it's telling me that these are my 4 brokers that are running at the moment. Okay, if I jump across to, so these are my 4 brokers here, 1, 2, 3, 4. So as we do a bit of benchmarking, we will start seeing some data flowing through to here. So this is the brokers expose a JMX port. Then there's a squid proxy that's basically scraping that JMX port, and then it's pushing it up to Health Plus. And I don't need to do any I don't need to save any metrics on my laptop or store it in topics or anything like that. Okay. So once you have your metrics, so these are the key JMX metrics that you're going to have a look at. It's hard to read. I'm not going to go into much detail, but the record side average, the batch size average, etc. If you use Prometheus and Grafana, feed these all into Grafana, and then you can, there are actually quite a lot of Grafana open source dashboards available that you can just download. They will have all of these metrics available, and you can just sort of chart how they trend up and down as you are doing your test. So now I'm going to kick off a producer and consumer perf test. Okay, so this is the script. This is on my GitHub. It's just a simple shell script. So it has a function for recreate topic. So it actually creates a few different topics as it creates, depending on the message size. We're going to test with message size of 100 bytes, 300 bytes, 500 bytes. If I try with 1 kilobyte, then I run out of memory, so I can't do it on this machine. And then we're going to basically push in, it just retains data for 15 minutes. We're going to print the metrics. We're going to send in 2 million messages, each of 100, 300, and 500 bytes. And we're going to do it for AX0, AX1, and AX all, right? So we're trying the different acknowledgements things. So we get all 3 of these different message sizes, different AX schemes, and different record sizes, and then see how they compare. So it will simply iterate through them. It'll create the topics, and then it's going to run the Kafka producer perf test command. here that I showed you earlier. So benchmark dash $I, which is the size, so 100, 300, 500 bytes, the number of records, of a metrics variable telling it what we want to save, the record size, the throughput, and some producer properties. And this will feed into the brokers that are running on the laptop. And then it also starts a consumer, okay? At the end, it has to do a bunch of awks and seds and things just to parse the data, because both consumer and producer give you tons of metrics. So all of those JMX metrics you saw earlier, so it prints them all out. So I need to do a bit of parsing on those to get things like the megabytes per second for produce, megabytes per second for consume, number of megabytes that were sent in total, and then just print all that stuff and make it easy to sort of digest. So I'm going to kick that off, and then I'm going to jump back to my slides and let this run for a while. So it's saying running a benchmark to determine. So now it's creating the topics. So it'll create a topic for 100 bytes, 300 bytes, and 500 bytes. And then it's saying running a producer for 2 million messages and act 0 into topic benchmark 100 bytes. And when that finishes, it'll check the consume, see if all the messages arrived, then it was successful, and it'll record the megabytes per second for that. And then it'll move on to the next one, the next X. When it's finished, the 3X, it'll move on to the next message size and continue going. So it has to run, I think, 12 or so producer perf tests. So we come back to that in just a moment, okay? Okay, on consumers. So the way a consumer works, consumer is like a subscriber if you're a messaging person. So Kafka consumes, it fetches batches of events. It's not single, it's not event by event, it's the whole batch. So if you batched efficiently, then it will consume efficiently as well. So the consumer basically says to Kafka broker, I need to fetch a message. It sends back a batch of messages and you do something to them. So whatever your Go or Java or Python code is doing, you do it here. Or maybe you're syncing it into a database. Maybe you're sending it back out to a messaging system. Maybe you're sending it to like a SaaS service, whatever. And then it commits an offset to say, okay, I received that batch. I'm finished processing that batch. Give me the next batch. And you just simply continue like that. That's how a consumer operates. And as we heard in the last talk, the whole basis of scalability is partitions. And partitions are, I agree with the last talk. It's a design time factor. You have to think about it when you create your topic. Once you've created your topic, you really can't change it. You have to recreate your topic. Now, there are ways of recreating your topic and migrating your data and doing all that stuff, but it's not easy. So at the start, the advice I give my customers is simple topics, simple consumer, one partition, keep it simple. If you need to do some scaling, then do four partitions or 12 partitions, like if you really need to scale a lot. If you running something like a Kubernetes-based application that you really need to be able to scale up, say at month end, if you're a bank on payday, something like that, then give it 32 partitions. But it's actually very rare that you need to go much higher than 32 partitions because the capability of Kafka to feed data through a partition is pretty high. One of the things that sort of keeps coming back to me is, well, exactly how fast can a broker go anyway? And people are very dissatisfied with it depends. You know, it's a very unsatisfying thing to hear. And I find as a general rule of thumb, the number to keep in mind is 45 megabytes per second per broker, right? So if you have a 3-broker cluster, it should be able to produce at 45 megabytes per second by 3, 135 megabytes per second produce. As a general rule, right? There's all sorts of variables. How big is your VM? How fast is your network? All these sorts of things will vary it. But as a general rule, it tends to land more or less around there. 45 megabytes per second produce for TLS encrypted data. If it's not TLS encrypted, you can double it, but in 90 megabytes per second per produce. Consumers, as a general rule, can go 3 to 5 times faster than a producer. So if your system is has 3 brokers and it's able to produce at 135 megabytes per second, and then literally the brokers are redlining and everything is 100%, your consumers should be able to consume at 3 to 5 times that. So that's somewhere around 400 to 600 megabytes per second. General rule, right? You will always find exceptions, but I always find that a good guide. Okay, so once you've picked your number of partitions, and supposing normal operating state, you're running on Kubernetes, you don't want to eat up too much of the worker nodes, so you just run 2 consumers, and it will just evenly divide the consumers over the partitions. They get 2 each. Your system runs just fine. And then at month end, you would say you reserve more worker capacity on the Kubernetes cluster. You have to start up more consumers, and then it goes to one consumer for each partition, and we're getting double the throughput on the system, right? Assuming that your consumers can keep up. If you have more consumers than partitions, then you're just wasting resources, because that last consumer can't get assigned to anything. You cannot have two consumers assigned to the same partition, so it just sits there and does nothing. It starts up. And it will poll the Kafka brokers and say, hey, is there any partitions that are not being processed by anyone because I'm waiting? And as long as they're all allocated, it won't do anything. If any of these fail or get restarted or something like that, this one's already running, so it will get allocated more quickly. So you could think of it as a standby sort of technique, but generally it's this sort of thing would not be done. And just like producers, there are a bunch of key consumer properties that let you tune your consumer and say, well, am I tuning for latency? Am I tuning for durability or for availability? And you can tweak these. And the first white paper on my thing goes into real detail for each of those 4 different goal types. What do you set these various consumer configurations to? Okay, anyone can, by the way, can ask questions as I'm going through. I realize I didn't say that from the start. So feel free if you have any questions, or we can ask at the end. Okay, same as producers, there are JMX metrics for consumers. Too much, in my opinion. You kind of get overwhelmed with Kafka metrics. There are 115 metrics, I think, on a broker. And it's just like everything's instrumented to death. But there are some really key ones: the fetch latency, the fetch size, the commit latency. So you look at these, and as long as everything's kind of tracking in a normal pattern, you're generally good. You're really looking for outliers whenever you're looking at trends for these. Okay, so we'll do a couple of things. So now if I go back to my results, we can see that it's been running a bunch more now. So each pair of lines is a new result. Let me up the thing so that you can see a bit more. So running a producer for 2 million messages, X1 into topic 300 bytes. And it came back, it produced at 17 megabytes per second, and it consumed at 52 megabytes per second. Okay, and you will see here, now I do get some strange results from my laptop. So for, say for the top one, 300 bytes, X0, we saw a produce of 27. When we change X to 1 and we said we need acknowledgement from the broker, it dropped from 27 meg per sec to 17 meg per sec. When we then dropped it to X all, I want all 3 brokers, because my min in-sync replicas is 3, it dropped from 27 to 17 to 6, right? So this is the cost of durability. If we're saying, I want the brokers to tell me that they got the data, and second, I want the brokers to tell me that they got the data and all the brokers got the data, then this is the price you pay. Right, you're running at about 25% of the throughput that you would be run if you're just blasting data into the system and you didn't care whether it lands or not. And you might do that for a logging system. We sometimes see it for clickstream data. Some, data has different values. Some data is critical, it's really important. You can't afford to lose a single message. Some data, if a few minutes is gone, it doesn't really matter. You can either replay it or it just gets replaced by later data, whatever the case will be. So this gives us, this wraps up the Kafka producer perf test and the Kafka consumer perf test into a single line result for different X settings, for different message sizes. So you should feed in the real message size for whatever your application is doing, right? And message sizes in the hundreds of bytes into low kilobytes is quite normal. If you have message sizes like going up into megabytes, the biggest I've seen is 80 megabyte messages for an insurance company. It still does it, it works, but it really slows the whole system down as it tries to push through and sort of checkpoint such large messages flowing through the system. Typical sizes are usually a few hundred bytes up to a kilobyte or so. Bear in mind that if you're using schema registration and you're doing protobuf or JSON schema or Avro, your message sizes will be considerably smaller than if you're doing regular JSON or XML or something like that, okay? So that's running through. Now I'm going to go back to my console. So as we can see, my volume health is okay. Oh, no, sorry, that was the slide, because I was wondering why is it showing 5 brokers? That's the slides. Let's go to the actual console where I have my 4 brokers. And if I look at my producers, we can see the activity it's flowing through, and failed produce request is 0. So everything is flowing okay. And on the consumer side, we can see all consumers are working. We have no failed consumers going through. general throughput on the system. So this is varied, right? Depending, the data is quite compressed because it only shows last hour as the minimum granularity. But these are the different tests that we were running. So I recommend having some sort of a benchmark application that you can fire up against your Kafka cluster. You only need to retain the data for 15 minutes. And sort of keep these metrics so that you can compare and see, is my Kafka cluster operating normally today? Very important as you're doing things like if you're going to upgrade your system, if you have new client onboarding to the system with new producers. That's the most common way of really affecting performance on a production system, is introducing new workload that sort of you can't really isolate. And you really need to check and make sure that it's not misbehaving on your system and affecting other clients. Okay, and then the actual topics that we have. So these are the topics it created. So benchmark 100 bytes, benchmark 300 bytes, benchmark 500 bytes. And so it's doing the 500 byte benchmark at the moment, and it's producing at about 14 megabytes per second. And consumption is 904 kilobytes per second. I think that's the metrics are lagging. So that should sort of, that will update as it gets new metrics from the consumer. So that's still running. I'm going to leave it running in, oh, it's finished. Okay, so the last test was 2 million for 500 bytes, axe all, and it was 13 megabytes per second. The reason that this number sort of goes up and down is because of the compression factor for different size messages. So when you have 500 byte messages, and you have like 1,000 of them together, you actually get a better overall compression factor for this. One of the things I don't have here that I have in another version of the script is to try the different compression factors in another loop. So try with gzip, then snappy, then zcat, then there's a fourth. I can't remember what the fourth is. But you can try all four because you will get different results for the 4 compression algorithms depending on the type of data. So very, very numerical data will work quite well with zcat. Very, very texty sort of data will work quite well with snappy, and they'll have different CPU levels as well. So you should actually, for a high throughput system, you should pick the compression algorithm that best fits each topic and say to the producers for this topic, I want you to use snappy because this is very, very texty sort of data. And I know I'm going to get a much better compression factor out of snappy than I would say with zcat. That can make an enormous difference on the throughput for systems. Okay, just jump back to the slides and wrap up. So recommendations and conclusions. You know, have a significant and representative load. So the message size should be the real message size that you're using. Your clients should be in the place that your clients normally run. So don't run it all on your MacBook if you're running production, say on AWS, right? So try and set it up in a representative way. Consider having a test cluster, tweaking your producer and consumer properties. The white papers talk a lot about which ones to focus on. Leave space for growth, the number of partitions, you know, every single Kafka talk ever has talked about partitions, and monitoring, etc. So the 2 white papers again, optimizing your Apache Kafka deployment and 99th percentile scale. Again, yeah, recommend, please join the communities. And you're obviously, you know about the meetup already. I think the Slack group now has over 40,000 members. So it's a great place to go and ask questions about how do I do stuff, etc. So busy and active. And we actually have there is a Confluent event coming up in May. Feel free, if you're interested, then just Google Data in Motion. So we're having a whole bunch of speakers come to Singapore to do a talk. So once again, I'm Mark Tian. So find me on LinkedIn if you want to connect. And that's the end of the talk. So quite happy to take any questions that anybody may have on any of that.
Last message. Yeah. So which approach is good in terms of message size and compression? So less message with big size is okay without compression, or many message with split without compression is okay, or any kind of size we should go with the compression, that would be best.
Any type of size, go compression. That's definitely my recommendation. So compression will add CPU to your client. So you can actually compress at the producer, or you can say, I want the brokers to compress, right? That's actually a bad idea. Compression of the brokers is just increasing the level of CPU for all your brokers. And you're asking the brokers to do 2 things. Well, your brokers should really just be organizing your data and streaming it out. They shouldn't be compressing. So assuming your producers do the compression by setting compression.type equals something, on your producer. You're going to have marginally more CPU on your producer, but just like any other compression anywhere, like on Spark or on Hadoop or anywhere, there's a small overhead, but it's so worth it, because by the time you've completed compression, you can expect at least a 2x, and you may get up to 8x reduction. And that means that your broker file systems drop from like 1 gigabyte to 80 megabytes, right? If that's, well, an 8x, 150 megabytes, right? So you really get dramatic drops in the amount of storage needed on your broker once the data is compressed. So I would say in all cases, compress. Yeah. Any other questions? Sure.
Hi, Mark. Thanks for the talk. Really love the live demo. Always love those. Just that you mentioned that real-time payment systems is a big thing with Kafka. Just wondering, like in a use case like that, is there a requirement to like guarantee response times? And if so, is there anything within Kafka that guarantees response time, or do we have to handle it outside using application?
No, unfortunately. So it's true, yes. Payments are really just more sophisticated microservices, and they have tighter dependencies. Well, not tighter dependencies, but it's usually more services within a single system in order to process a payment. So the sequence and the timing from step to step starts to matter a lot more. And you never want a processing payment chain to get stalled on any particular, on a message or on a service or anything like that. So actually the end-to-end processing time for the payment as it's produced and consumed by lots of services becomes more important than the actual response time from each producer. All you can do for each producer is tune it as best you can, reduce the latency while keeping the durability, because this is the trade-off you make, right? It has to be durable, and then you tune. You can't do it the other way around. So once you've done that, and you know, a fast producer should be operating in low double-digit milliseconds, right? So 20, 30 kind of milliseconds. If you really, really push it, then you get into teens milliseconds. Getting below 10 is an unreasonable kind of goal. There's nothing in the client that says this needs to process within X milliseconds, and I want that kind of a latency guarantee. Now, there are ways of doing priorities for producers into topics, and the way to do it is using partitions. You can there's a technique for assigning some partitions as priority partitions, and the other partitions as non-priority, and you can sort of you can have a fast path and a slow path through across various partitions to the same topic. That technique is sometimes used. But as a general rule, you often don't need to. Payments need to be fast, but in terms of how quick a well-operated Kafka system can run, it's easily capable of sort of getting payments back that quick. It's not like stock trading, right? Generally, there's a tolerance for a second, 2 seconds, 3 seconds, which is quite easy for a Kafka system to achieve.
Thank you.
Okay. Any other questions?
Do we have any final questions for both Mark and Ming-Xin? Or whom?
Yes. Any site that we can refer to the what kind of compression suitable for what application?
Yes. So the question is, where would you find more information about compression? Is that right? The different algorithms. Actually, not many. So I think the Kafka Definitive Guide, the book written by Gwen Shapira, I recommend that. That has some detail on different compression. And there are a few Kafka Summit talks. So the annual Kafka conference, all of that material is online. So you can go to our page and click on Kafka Summit. There were a couple of talks on this subject as well. To hand, I can't remember who did those, but I've sort of gone and referenced them before. I find with compression, it's never really a case of finding the best algorithm and just sticking with it, because it changes topic by topic depending on the shape of the data. So that's why I use this type of a benchmarking tool. Like I'm working with a customer at the moment that's just sending gigabytes of data into a Kafka cluster, and compression is like the single most important thing. And I wouldn't assume that any of the 4 algorithms works best. We have to test and see which one yields the best result for that type of data. So I'd say go to the conference material first, and then if you can get the PDF for Kafka, the Definitive Guide, we have that as well. And then just try all 4 and see which gives you the best result.